How many of you guys are afraid to fly in an airplane? Is it the height that scares you, the shaking that you anticipate, or is it the combination of the both? For those that say combination, I'm here to open your eyes to turbulence and the general impact it has on the aviation community. When you study aviation science as I do, you learn the little facts and statistics that allow you to proudly say that aviation is really the best source of transportation, even considering the best and worst types of turbulence. In order to understand the concepts and the effects of turbulence, we're going to have to answer a few questions. First, what is turbulence? Then, what causes turbulence? And how do pilots avoid in flight turbulence? To begin, let's start off with what is turbulence? According to a graphic drawn by John Fraser of CBC News, turbulence is a sudden, violent shift in airflow. If you like, you can associate airflow with the ocean waves in the sense that they move similarly. Now, when a disturbance hits an airflow, the effect is the turbulence that is caused. Depending on how violent the disturbance is, determines how intense the turbulence becomes. There are four intensities to turbulence. Those are the most common, which is light turbulence. It's also very subtle, and it happens in every flight, which is why it's so common. Moderate turbulence, which is also pretty common if you're a frequent flyer. It may spill your drink, and it may cause you to feel some tension against your seatbelt. The next two are labeled violent turbulence because they cause damage to both persons and property. Severe turbulence causes damage to persons because it's the leading cause of turbulence-related injuries. Extreme turbulence is very rare. It's this type of turbulence that you probably will never experience in your lifetime, but it causes significant damage to the aircraft itself. Next, let's talk about what causes turbulence. Turbulence can be caused based on altitude that you're at, that the aircraft is flying in, or location that it's being created. In that sense, we're going to talk about three types of turbulence. That's convective turbulence, mechanical turbulence, and clear air turbulence. Convective turbulence is the most common cause of turbulence according to Dr. Sherry Krause in her textbook, Aircraft Safety. It forms at lower altitudes, but depending on the intensity of uneven surface heating, convective turbulence can go from low altitudes to higher altitudes, which is about like 22,000 feet. It's produced in areas that are barren, sandy, or rocky. When the sun unevenly heats those areas, that produces convective turbulence. Mechanical turbulence is created when air flows over obstructions such as buildings, towers, and trees. This causes a problem if there's a building next to a landing strip and someone's trying to land or take off. Clear air turbulence is one of the most dangerous types of turbulence because it there's no indicators. Unlike other turbulence types, there's usually a cloud or temperature decrease or a temperature increase that can signal that there's a turbulence in the area. There's no indicators for clear air turbulence. Next, let's talk about how pilots avoid in-flight turbulence. To start off, pilots are already extremely familiar when it comes to the different types of turbulence and the different intensities that they come in. However, they do make it a point to try to avoid areas that have higher turbulence in order to maintain comfortability of the passengers in the back. So, in order to avoid turbulence, first pilots will start their nav logs. As stated by my instructor slash pilot, nav logs are adjusted between 3 to 4 times before the plane actually leaves the airport or actually takes off. This is to ensure that weather, such as warm weather that produces convective turbulence, is not produced in the flight that they're going and the path that they're going, so that the passengers would be more comfortable. Next, if a pilot is experiencing turbulence, they have the option of either reducing their speed, because this helps in the way that they will not be fighting against turbulence, or they can increase altitude, because increasing altitude, there's less turbulence at higher altitudes than there are at lower altitudes. And if a pilot is unable to predetermine turbulence, they will turn on their the seatbelt lights. That way, the flight attendants know to tell the passengers that it's not safe to move about the cabin. As you can see, pilots have a well grasp over the situations that involve turbulence because they are trained so extensively. So the next time you're in a plane and you get the pre-takeoff jitters, just remember what turbulence is, what causes turbulence, and how your extremely trained pilot will handle in-flight turbulence. With this in the back of your mind, you'll have a better understanding of what turbulence is. That way you can rest easy and have less to worry about and focus more on the view outside your window. Besides, who wants to miss out on a view like that worrying about something that will probably never happen?